Zoom call to join
the teams. Well, it's 3 minutes past, so I think why don't we lead off? So thank you very much for joining us today. I'm very excited to show you the data from Molport. We've got amino acids and sugars here, and how we can search them and move them around and go in and find what you're looking for. But I'll let Imants do the first intro, as Imants was the person that emailed his user base.
Hi everyone. So at Molport, our mission is to radically simplify chemical reagent ordering. And so most users know us by aggregating screening compounds and being a one-stop shop to buy screening compounds, either small libraries, very big libraries, library replenishment projects. And I met Richard approximately half a year ago. Came across Adroit, and I found it very interesting platform. We had a chat with Richard and kind of stopped there, but a bit later, we were making a few custom-built libraries for clients. This is something that we are currently doing more. For example, today we'll talk about amino acids, sugars, covalently binding compounds is also being created. So it occurred to me that Adroit is such a wonderful platform, so easy to use, so intuitive. It's a perfect platform, I think, to explore such sets. So I approached Richard. Offered, hey, why don't we do a webinar, joint webinar with Adroit? So we came with the data to Richard, and these sets have the structured data. They have calculated clustering data and panes, filters, etc., etc., etc. So together about 70 or so fields, and of course structures. And Excel is not a good way to explore them. There are other tools, but I found the Adroit such a great way to explore them, and I'm so happy to be here and also see myself how it can be used to explore such data sets, and hopefully these sets will be available for browsing on Android platform. So thank you for the opportunity to co-host with you, and thank you everyone for joining. To those that joined us in person and those that will be watching us in a recording, as it's popular these days. So thank you for joining us today, and Richard, thank you again.
Okay, thanks, Imants, and thanks again for doing this. Well, I'm just going to give a brief intro to Adroit DI. So I'm giving a demo today. It's not a training session, so I'm going to go through relatively quickly to show you what's what. Hang on, here we go. To show you what's what. But if you've got any further questions, just let me know. So when you log into our platform, you get a blank kind of canvas. So this is what you see. I'm going to start with one that I have already uploaded a few things to, because when you upload, it takes a couple of minutes to process. And what I've done, I've uploaded the amino acids library here, which we can search. So you can double click. We use Catcher for the visualization, which in turn uses Mu for the 3D. And if you're aware, it's a standard drawing tool that comes with everything. And you can, within the libraries, sort of manipulate them. When I was doing the user interface for this, people were saying to me, can you make it more Excel-like? So we've done our very best to do that. So we pulled things in and made them so they're very Excel-like, and you can add your own data and do all sorts of cool stuff to it. But that's just a sort of brief overview of how things look. But I thought I'd sort of drive straight into it. Just doing a little testing before we started. Left a search there. So as you can see, we've got the sugar libraries here, the sugar and amino acid library. And I thought probably the best thing to do would be to search for something and show you how you can go in and search for different things. So I put together a couple of just little templates. So we've got fructose, galactose with the rings open, pentose and hexose, A, B, and C. So that's quite interesting because they are chiral. So you can see that if I get all three open. It's a little bit of fancy mouse work here. That they are similar, but chirally quite different. And so we took quite a lot of time to ensure that we managed to get the chirality correct. So if you look through the first one, it's up, down, up, down. Oops, move this a little bit. Up, down, up, down, up, down. Wrong answer. Up, down, up, down, up. This one is down, 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 up, up. And this one is down, down, up, up, up. So they're correctly depicted. I can go through and sort of demonstrate all of that. So why don't I start off with searching on a substructure search for the A version. I'm just going to copy that. So yes, just to prove that this sees these things as different, if I hit the remove duplicates button there, it will go through and it will remove duplicates. And as you can see, no duplicates are found and 6 unique rows remain. So we do understand the structure of the sugars, which are ostensibly pretty similar. And if you've got a library and you've been doing some work there, you can just search right across all of the different files that you have. So for example, we can substructure search for the hexase A, and of course it comes up because it's there. It's not the amino acids, but it is naturally occurring. So it's going to come up in the sugars library. I think there are quite a few there. So we're waiting for that to just finish off. There we go. So you can go in and then look through and see all the hits that you've got that understand that. You can then, I guess, filter by different things. So if you're particularly bothered about the traffic light, you can pull that over, unlock that column. So there, as you're scrolling through and looking at the hit results, you can then go and say, okay, the price is important to me. So I want to make sure that the price is less than 500 MIGs. What should we do? Less than 1,000 for this type of compound. So apply that. And so there we go. The filter has come down from a few thousand to 263. When you're doing the Boolean search, it pulls the column that you're looking for in so you can see it, because in this particular data set, there are lots and lots of columns, 81. So if you're searching and the column you're searching on happens to be miles over to the left, it's not that handy. So, okay, we're down to 267. We can add another one. So the price at 250 is less than 100. So hopefully this will drill it down a bit more. 108 rows. There we go. And let's see what else we would search on. Perhaps the traffic light is non-empty. So one of the things with Boolean searching, it's really hard to search for cells that are empty. So we've put a feature in here that you can do a non-empty equals contains, etc. So that you can find where there are gaps in the data or not. So there we go. So you've found those results. I showed the whole thing. So you've got 102 rows. So you've very quickly gone down from the 30,000 to 112, sorry. And you can export those as a zip file, but we don't need to do that. I guess it's going to be fairly big because there's a lot of columns. You can export those, or you can import and export them. So that will have exported. And then I'll show you how easy it is to upload. So there are the hits. So this is a new platform. What you're really looking at here, not to go into tons of detail, is a sharded index of the data. So when you upload something, it gets analyzed for quality, put into an elastic database, which means the searching is very fast and it's very secure, and it understands the chemical structure as well. So there you go. I've just uploaded the hits there. There are also some pretty nice features. So if we go in and look at this large library, sorry, this is just the library of the racemate alanine, the L-proline, the L-arginine, the D-proline, the D-arginine, which are different. So if we go and do a search for this one, oops, there we go. And then we draw the structure into here, and we search right across substructure across all the files. We can actually do exact as well, which is pretty quick. So there we go. So there's 2 in the library and there's 1 in the template. So let's go and have a look, see which 2. There we go. So this might have been me messing around with the library, of course, to add an extra one in. And there might be different availabilities, but there are 2 in that one. And there's just 1 because that's where I copied and pasted it from. And then, of course, similarity search. And there's Tanimoto, which seems to be the one that absolutely everyone uses, Tversky, and Euclid Cub. I wish it had been Cub Euclid because it's quite hard to say the other way around, but there you go. And so we can do a similarity search. And then we've got 54 hits in the amino acid library. And then again, you can search, again, by sort of price is probably the most reliable searching. So 5 milligrams, I want it to be greater than unusually 50, for example. And you can further refine things through. So there you go. You've got 32 rows that have come up with price greater than 50. Oops, sometimes this interacts with Teams a little bit. There we go. And you can, again, download all the rows, all the filter result as an archive. That's hits. So one of the things that people have in their data is that quite often, if you're working away, you want to merge things. Let's pull that back up here. So you've got hits, and you can merge at the top level. So you can, let's just do that again. Actually, I'll show you what happens if you want to merge the top level. So if we do we'll do similarity, Tanimoto, so you can search it. So you've searched across, and I've just uploaded that. So there's 32 hits in the hits because I got them, 54 in the unrefined, and then I think there's 2 there. You can then go and say, right, you know what, all of the similarity search, I just want to get the matched rows with all the data. So all the data on the hits, pull that in. And so you can see there's quite a large number of columns. So as you probably noticed, the molecular structure is a row and the data associated with it is a column. So what that has done is pulled all of that data together, 88 rows, if you're going to add that all up, I'm sure it's 88, and combine the columns of data together. So that's a sort of simple combination. So if we do that, actually do it a couple of times, I can show you the feature. It's 2. So that if you're compiling data up, the problem that you're going to run into is combining that data. It's 4, for example, combining that data together and keeping the data integrity whilst not propagating a huge amount of data. So I pull that data together with all those hits. We just clear that. So here we have, these are the 3 files that are absolutely identical for the purpose of this. If you go and then you combine them all together, never type in a demo. So combine them into one. It's not removing duplicates, it's tacking all that information together. So it'll be 3 times 88, and all those columns will be put together, but in a sensible way. So if the data is duplicated, it won't add an extra column. I think I probably picked something that's going to take a little bit longer. There we go. So that's all together 264, and there you have all the data. Now, you can do this a couple of ways, but one of the really smart things that we've done is that you can combine all this together. So it's 88 plus 88 plus 88, which is one data set there, and then this is all them combined. So I can merge that, and I can remove the duplicates. So deduplication. And this is the clever bit, because it will go through and look at using fingerprints, our sort of evolved version of fingerprints, and it will look at each of the molecules as it goes through, and it will look at the associated data. If the associated data is identical, it throws it away. And it's a good example of why you want to do that, because if it just tacked it all together, you would end up with 161 plus 161. So, you know, the best part of 740 rows of data pulled together. But because it doesn't do that, it might take a little while because there's an awful lot of associated data. Because it's got a smart way of handling the data, it preserves the integrity. Now, while you're doing it, it goes to read only. So whilst I'm waiting for that to complete, there are a couple of other fairly cool things that you can do. So I'm sure you've been in a position where you're trying to get a load of hits and export it. So this, you can copy it and paste it, or same data set, you can export it, to Excel, or you can export it to a CSV file, or you can, of course, export it as an SD file or a zip, whatever. So if we look at the Excel, there we go. So that is the Excel file, and then I'll paste in, this is my demo user, so I can't use it properly. So you can see, you can very quickly cut and paste in, so you're not tied into using Excel, SD files or whatever else. Oops, there we go. Hopefully that's completed. No, not yet. It takes a little while because if you do duplicate on all these rows, it's got to go through and make sure the data is correct. So the other thing I was going to do is show how we can handle the alanine and imants, which is the one that's not occurring naturally in nature. I can never remember, is L, D or L. I should remember that, especially in this job. We'll find out, shall we?
Be in nature, yes.
So yeah, so D should be in nature. So as we've got sugars and we've got amino acids, if we do a draw a structure here, done, and do a search. So let's see, we'll do selected files, but we won't do those. We'll just get rid of those, and we will just do it through those two. Do a substructure search on that and see what comes up. So that's in nature. Indeed, there should be a few sugars there. And there we go. And so there are 4 sugars that show up. There we go, with all the data. So they're the 4 sugars that show up, and there's the structures. So you can open multiple windows. The little view in the Excel-like file is a sort of quick look-see. Then you can open windows to really go and have a look at the structure that you found, and it will show up. If the 3D data is there, it will show up in 3D. So then let's go back into the file. Oh, the deduplication's finished. So there we go. So actually, in all of this data, we just amplified it up. And so it's come up with, deduplicated on a number of rows, and it hasn't propagated over to 750 bits of data, which is important. So if we then go into the amino acids template, not to highlight it, and get the L version. So if I'm correct, this shouldn't show up in nature. Is that right? So if we, it should.
Yeah.
This one should. Let's see if we, search your files. There we go. I kind of propagated quite a lot of files here. Oh yeah, that's 4. Okay, right then it's the L. So you can get the idea. You can very quickly go in and just get rid of that and manipulate the data around. Is there anything you don't think I haven't shown yet, Imants? I can show a bit of adding data, so you can manipulate and add some more data in. So if you want to annotate things yourself, so I can show that. So let's go. I'm just going to search on this as well. So for this drawing package, you can actually upload a mol file. You can handle various different formats if you're pulling in. So you don't have to cut and paste or be able to draw it. You can just pull things in as well. To go, oh, That one does show up in Nature. Not to worry.
Is there a way how to add additional columns calculated, like Lipinski rule of 5 or something that's not in the data set but would be considered kind of a standard
Yes.
field maybe to explore?
So if I just reset this, so I'll use this data set because it's a lot of columns of only 5 rows. It's pretty quick to add stuff. So you can calculate, you can search for what you want to calculate, but it does have Lipinski rules, smarts, canonical smarts, Inchy keys, ring count. So you put the calculate Lipinski rules in there. And when you calculate it, it comes up with a neat little plus minus equals indicator to show that it's a calculated property. You can also edit stuff in bulk. So if you want to go in and manually change that, so bulk edit, so just change that to 6. There we go. Put that in there. The other thing that you can do that I think is quite handy for people that have been trying to throw around data is that if someone has put, so you can add your own column, user defined, and it's text to numbers. So if you put in text A, B, C, A, B, C, 1, 2, 3. So that's going to add a column called text to number with A, B, C, 1, 2, 3. And then if you've ended up with a data set that has text and numbers, if you then try and Boolean search it, you're going to find you don't have greater than, less than, because someone's put text in there or it's been denoted as text. So what we can do is a very quick fix. We can just click a button that says make it a number, and that will keep this original column. It will add another column in just here with _1, or depending on how many you've done, and it will have stripped out the text and just left you with the number. So then you can go back in on there and do the less than, greater than, equals. So that's kind of neat. The other thing that you can do, not with calculated properties, is if you've got large data sets that you don't want to have in this form, so structures or all sorts of stuff, if you dropped in data that has a web link, most places won't allow it to be an actual web link, but here you can just click something and it will make it a web link. Now there is no web address for that, but if I went in and I added a row with my own molecule like this, put a cyclopentadiene in there because it's not that column, and I forgot where we made it a website now. You know, I'll just put it in here. You can do that. So then you can add a structure, add the row to the data set. It will add its own entity, and then we can make that a web link and then click on it and it goes to our website. So there's some pretty neat stuff you can do with managing tables. So you can add rows, add columns, and you can move stuff around. You can delete them, you can hide it, hit apply with the columns. And I think I sort of pointed out you can sort and various things, remove, hide from here as well. You can sort it. It's not going to sort in any of this because the data's empty. Yes, but you can, lock columns like that and move it around, because the feedback I had when I was putting it together was make it more Excel-like. So that's a quick overview. And I did say, I think, anyone that came along, I'm happy to give you a no-cost trial for, however long you want to, not indefinite, but a decent time for you to check it out. If you've got any questions, I've just suddenly looked at the time and we're sort of running away with it. So yeah, thank you ever so much for watching. Do you have any questions? If I have a look in the chat. Doesn't seem like we've got any in the meeting chat at the moment. But in the interest of finishing on time, thank you ever so much for watching. Imants, any questions, or do you want to wrap up? And thank you very much for your time and for coming along. And obviously there's a recording available if you want to go over it. Any questions, please feel free to reach out to me or Imants directly. Imants, I'll let you wrap it up.
Thank you for a nice demonstration. Really interesting. So, hopefully more people will get access to explore and also see our libraries in it. Thank you for organizing this event.
Thank
Thank
you.
you
Thanks.
for joining, everyone.
Thanks.
Yeah.
Thank you. Much appreciated. Thanks for coming along. Okay. Have a great morning, afternoon, evening, wherever you are. So thank you very much. Thanks. Cheers.